Hello again and welcome back. So today we're going to talk about common mistakes to avoid. Exponent laws, that those are the specific mistakes that I've seen throughout the years that students make. So I want to go over about 10 of them, probably with a couple of bonuses. So let's go ahead and do that. The very first one that is very common, if you have an example like minus 5 squared and there's no bracket or nothing like that around it, and a lot of students, they say that, oh, that's minus 5 squared, so minus 5 times minus 5 is positive 25, and that is incorrect. The reason is that that negative is actually outside and only 5 is being squared. So the answer to this one is negative 25. If you don't see a bracket, right, the brackets are very important. If you don't see them, that means that just the number is being squared. All right, so that's very different than if you put a bracket around the entire thing. If you did, that's a different story, and that is true. So if you had minus 5 squared like that, then of course that would be positive 25. All right, so let's go to the next one. X to the negative 2 is equal to negative x squared. Now, I do have to say that a lot of students at times they make up their own rules, so there is no such a thing. This is actually doesn't even up. I don't know what that is and how that is, but this is actually not true at all. And the answer to this one is basically your negative exponent will end up being a positive exponent, and you have to say 1 over x squared. And that's what that is. Simple as that. There is no such a thing that negative comes in front of the variable when you have a negative exponent. This is not true at all. That's why that's what I have. I have two columns. One is a no column, obviously. The other one is a yes column. So no means don't do. Okay. Next one, negative 1 all to the exponent of 0. This power statement, a lot of students will make that mistake and they call that negative 1 and they just ignore the 0. Remember, anything to the exponent of 0 is 1. Okay, so the answer to this power statement is 1, not negative 1. All right, next one. This one is very, very common, and I see it all the time from grade 9 all the way even to calculus students. And sometimes I do understand, and for earlier grades, grade 8 and 9, and 10, what happened is that it is actually a information mistake. That means that kids and the students, they mix up what they should do. They forget the rules and they add instead of multiplying. At the higher grade, I think it's a transcription error, and you're so excited to see, especially if you're a calculus student, you don't pay attention to the actual algebra, and of course you just add. So obviously this one we all know that would be one of the exponent laws of power. We just multiply the two exponents. So 2 times 3 is x to the 6. That's what that is. All right, next one. This one is very important. This is actually very common mistakes. So most students, they look at this equation and say, okay, x squared equals to 4, therefore x equals to 2. And one answer, this is one of the answers, but that's not the entire total answer. So this equation has two solutions because remember, x squared, when you take the square root of x squared, both answers are absolute value of x. That means in this case, you have plus or minus the square root of 4, and that means will be plus or minus 2. And that's because of this definition right here. That's the definition of when you take the square root of x squared, the definition of it, the answer to this radical equation is absolute value of x. All right, so be aware, there's always two solutions, not only one. So that's a common mistake again. So don't do this. You make sure add the negative as well. Now, let me show you the other common mistakes, and this one is very interesting because now most students or some students, they actually overcompensate. They say, okay, well, if x squared equal to 4 is plus or minus 2, then the square root of 4 or the square root of any number is plus or minus whatever that value is. Well, that's a mistake. The reason you have up here plus or minus 2 is because of the definition, because of the square root of x squared is given by an absolute value of x. But here you're only taking the positive root of a square root of 4. So in this case, the answer to that is only 2. It's not negative 2. It's not plus or minus 2. It's only positive. Okay, only. All right. You're not solving an equation. You're taking a plus square root of 4, that's a positive value, and you get positive value of 2. Now, if you had negative, let me just write this down. If you had negative square root of 4, then your answer would have been negative 2, because that negative outside doesn't interfere with the square root of 4. A square root of 4 will be positive 2, and then you put the negative in front of it because it's multiplied by negative 1. That's what that is. All right, common mistakes. Make sure you don't do this, okay? Avoid it. Next one, students confuse the exponent laws. That's I see it all the time. So you have this is statement 2 to the a plus 2 to the b. Now, I randomly chose 2. You could choose any basis, but as long as they're the same. And then, of course, different exponents. Well, students say, well, they've got the same basis. We're going to add the exponents. And they forget that this operation is a plus sign. And when you have a plus sign like that, you really can't do anything. There is no law. So to simplify that, guess what? You can't simplify this expression. You let it be. So your final answer will be 2a plus 2 to the b. That's it. That will be it. Okay? Now, let's go to the next one. Number 8. All the time I see this. 0 to the 0 is equal to 1. That's not true at all, okay? Now, 0 to 0, this is a special case. 0 to 0 is actually undefined, okay? So 0 to 0, we don't know what that is. It's undefined, the value of it, but it's not 1. This is not equivalent to any number to exponent 0 equal to 1. Now, any number is true except 0. So 0 can't be to the 0, and that would be 1. That's the only exception with this rule. So number 9. Now, this is very common. Most students, they did get this right, but some students, they kind of get confused with exponent laws. Here, they actually think that they have to divide the exponents. Well, remember, one of the laws, division of one of the exponent laws is that when you have a division set up where bases are the same, you subtract the exponents. You don't divide the exponents. But in here, student usually what they do a 15 divided by 5, that's 3, and they write one of the bases, which is wrong. The next common mistake is that this is what they do. They say, oh, 3 divided by 3, that's 1. And then now we have 1 to the power of 15, 1 to the power of 5, and then they use the exponent laws and say, okay, 15 minus 5 is 10, so that would be 1 to the exponent of 10. That's wrong too, okay? So remember, that is not true. So what do you have to do? Use exponent laws, and this would be equals to 3, or the exponent of 10, and the entire power will be 3 to the 10. Okay, so that's that. Next one, number 10. This is another common one because of this is a negative exponent, and the students say, okay, we have to change that to positive because it's negative. So we're going to actually use the reciprocal of each of the term inside of this bracket. That's why it becomes 1 over x, and then plus, and it's negative 1 goes and becomes the exponent of y, and then it's exponent of x, and then you get 1 over y. Okay, that's incorrect. So this is actually what you have to do. Because if the entire thing is in a bracket, answer will be x plus y in the denominator, so 1 over. You have to use the reciprocal. Okay, that's the first thing that you have to do. Now, once you get to this part, can you do anything else to it? No, you can't. This is it. This is as good as it gets. Okay, so the entire thing gets flipped over 1, and then that's it. That's the final answer. Now, last one, number 11, that's the bonus one. What they do, they try to use the power of power rule, and they multiply this -1 by each of these exponents, and thinking that, okay, well, x to the -1 times -1, so this -1 and -1, they multiply, you get x to the 1, right? So that's what that would be. And then the same as y. Well, that's incorrect. Remember BEDMAS. So the entire bracket is -1, the same thing as number 10. So the first thing you have to do, you have to go 1 over. This is x to the -1 plus y to the -1. You do not distribute or multiply this -1 into the bracket with the multiplication of the exponents. You can't do that. That's illegal. Okay. And then once you get to this part, then you have to do some mathematical gymnastics. So then you go ahead and then you rewrite is as for each of the term would be 1 over x and plus 1 over y. That's according to the exponent laws. So each of these becomes positive when you do a reciprocal, right? And then the final answer to this one, when you do all the mathematical gymnastics, you will end up getting xy, and I'm going to leave that with you to deal with that, xy over x plus y. You're basically simplifying this reciprocal of this bracket, which is 1 over x plus 1 over y. You add these two fractions together, then you have to do the reciprocal, and you will end up getting this. Okay, that is the final answer for this one. So these in the blue column, all the yes. Okay, the red column is under all the no's. Those are the common mistakes that my students throughout the years have been making and still making. So my intention, my hope for this lesson is that once now you know this, you're never going to make these mistakes again. All right, I hope this was helpful for you, and check out the next video right after this. Okay, take care. See you in the next video. Bye bye.